landscapes, beautiful. I like the way it's beautiful. Oh, hey there, science fans. Sorry, I'm just thinking about eccentricity over here. And somebody told me that you guys need to know how to calculate eccentricity. So here I am, let me help you out. So let's take a look down here. We got ourselves a nice ellipse here with two foci in the middle. And as we talked about in the mini lesson, the formula for eccentricity is to take the distance between the foci divided by the length of the major axis. Okay, so we're gonna fill all that information out over here. And first thing is the distance between the foci. So we're gonna use centimeters, which is gonna be the smaller ones here. It says millimeters because they're talking about the little ones here, but these are centimeters. So I'm gonna put the line right in the middle of the blue dot, and then we're gonna do this to 1 decimal point. So this is looks like it's like 4.1, and we're always gonna use 1 decimal point for this because the Regents graders, they're very like particular. They're like a bunch of just like old school people that really follow the rules very strictly. So the major axis is the length of the whole ellipse, and that looks like, ooh, that is exactly 7. Wow, what a great day. This is exactly 7 centimeters. I'm pretty psyched about that. Okay, great. So 7.0 centimeters. And now we're gonna need to, yo, Aiden, can you help us out, buddy? We're gonna need to calculate eccentricity. Can you get your calculator out? Because Aiden, as you know, eccentricity is the distance between the foci divided by the length of the major axis. So let's take a look. So we got 4.1 divided by 7. Now we want 3 decimal points. We don't want to put all of that. So 1, 2, 3, that 5. Because of that 7, that 5 is going to round up to 6. Now we'll practice our rounding today. If that's news to you, it'll definitely help you out. But we want 5, 8, 6, because that 5 will round up because of that 7. Okay? Aiden, could you help us out again too? Can you go grab a reference table? Should be over there under the red folders. Now what we're gonna do now, Earth science fans, it's gonna be crazy, all right? Because we're gonna compare the eccentricity of the orbit we just calculated to the eccentricity. Go. All right, guys, so we just gotta compare the eccentricity of that to the eccentricity of Mars's orbit. So eccentricity of Mars is 0.093, and that number of our orbit is much higher. That's a bigger number than 0.093. So we'll say the ellipse on the left is more eccentric than Mars's orbit, and the explanation is the ellipse above has a higher eccentricity, which means that it's more elliptical. It means it's a more stretched out orbit. All right, Earth science fans, that's all the time I have for you. Thanks for tuning in. Until next time.